Compared to 20 or so years ago, vehicle construction has changed considerably. Manufacturers have strived to make them more fuel efficient by using lighter materials like aluminium, composites and plastics. There are also different joining methods used for structural components such as bonding and riveting. Also, the joining method used in manufacture may not be the recommended repair method. Some of these changes have led to many manufacturers offering extended anti-corrosion warranties, proving that they're confident that serious structural corrosion is a thing of the past.
You know, what you just said is all very true, Robert, but you know, corrosion assessment still remains a very important part of the MOT test, along with assessing any repairs to corroded or damaged parts have been done correctly.
Yeah, hi Jake. I'm not sure you'll think I've done this repair correctly, but I've given it a go.
Well, that does kind of remind me I need to clean out the bird cage when I get home.
Thanks.
But you know, it does highlight the point that anybody can carry out repairs to vehicle bodies, even though it's clearly better left to a professional.
Yeah, definitely true of the spot welds I've done here.
But you know, modern materials that are used in modern-day vehicles these days that you've already mentioned, along with the advancements in repair and joining methods and bonding processes, and in line with this, we've produced a revised version of Appendix C, which goes into all these repair methods in much more detail.
Great, and that's what we're going to look at now.
Yeah, and this revised version covers all aspects of corrosion repair methods in use. So we've got a specially prepared vehicle body shell monocoque over in the MOT testing studios that will help us illustrate some of these key points. So, do you want to go over and have a look?
Of course, yeah, right. Let's do it.
Right, so now we've got you nicely out of your overalls. I'm here in the studio. Here's the vehicle we prepared earlier.
I remember this from the last film we made about corrosion a few years ago.
Right. So this is going to test your memory then?
It is, but it's all coming back slowly.
Well, it's fair to say that modern vehicles don't tend to suffer from corrosion quite as much as they used to in the past. But it's still vitally important that we do inspect the structural integrity of the vehicle. Especially in the prescribed areas, yes? Absolutely right.
And as before, the prescribed areas, which we've painted white on this monocoque, are 30 centimetres from any mounting point. So testers obviously need to imagine a 30-centimetre radius from each mounting point, whether it be for steering and suspension, brakes or seatbelt mountings. And just to be absolutely clear, we're talking about an area this size. This is a 60-centimetre diameter sphere. So if you imagine a mounting point right in the centre of this sphere, we're talking about an area that's encased by the skin of the ball.
I know, and isn't it so much more dramatic when you see the thing in three-dimensional model like that? It really reinforces the area that we're talking about that testers need to consider.
Yeah.
And of course, the areas that we're talking about here would be any load-bearing structure on the vehicle to which testable items are attached. And that will include things like any load-bearing structure or panelling or any supportive panelling within 30 centimetres of any attachment point of testable items.
And we're not just looking for excessive corrosion here, are we?
No, no, we're not. Because within the prescribed area, we'll also be on the lookout for any deliberate modifications that may seriously reduce original strength. We'll be looking out for any severe distortion. We'll be looking out for any fractures or any inadequate repairs, in fact.
And that's because any of these defects in a prescribed area is likely to have a detrimental effect on the safety and stability of the vehicle.
Absolutely. And prescribed areas are covered in sections 2, 3 and 5 of the inspection manual for steering, suspension, brakes and seatbelt mounts.
So to identify the prescribed area for any of the components in those sections, we need to imagine our ball with the relevant component mounting point at its very centre.
That's right, and what we've done with this vehicle body here is we've selected some of those component mounting points, painted a 30-centimetre radius circle around it. Now, we haven't chosen all of them, but we've only highlighted a few of them for clarity for the purposes of this demonstration. And it's quite surprising to see just how quickly the vehicle structure is enveloped in those prescribed areas.
Now, I assume the effect of corrosion on the safety of a vehicle is dependent on how severe the corrosion is and whether or not it's within a prescribed area.
That's right. You see, a small amount of corrosion in an important part of the vehicle can render the vehicle unsafe by virtue of the fact that it's seriously compromised the load-bearing capacity of that structure.
Such as near to a suspension or steering mounting point, for example?
Yeah, that's right. And as you can see, this small area here on the top of the front suspension mounting is the kind of area we're talking about. But on the other hand, we can have excessive corrosion in non-structural parts of the vehicle, which will have little or no effect on vehicle safety. For example, certain areas of the boot floor maybe.
And vehicles are constructed in different ways. So on one, the door sill might be vital to its structural integrity, and on another, it may just be cosmetic.
That's right. And there are diagrams to help testers identify some of the main load-bearing structures on various types of vehicles in figures 1 to 4 in Appendix C.
Can we work through an example, say, for a seatbelt mounting point?
Of course we can. Let's take this lower seatbelt mounting point for an example. The tester will also have to assess the condition of the outer sill or any reinforcing panelling if the outer sill is actually covered with a plastic trim. They'll also be looking at the inner sill, the door pillar, the floor pan area, and any other structural part within 30 centimetres of that lower seatbelt mounting.
But in reality, most of this would be covered in plastic trim and carpet.
You're quite right. And as dismantling is not permitted, the tester can only make the best assessment they can by using finger and thumb pressure, OK? And in any element of doubt, they would pass and advise.
OK, let's assume we have found some corrosion within the prescribed area, say on this outer sill. How bad has it got to be before it's considered to be excessive?
Tell you what, why don't we go through a full corrosion assessment?
Now, Jake, I know this starts with a visual assessment for corrosion, followed by using finger and thumb pressure.
And that's correct. And only if we detect corrosion, and it's considered necessary, do we use our old friend, the corrosion assessment tool. And we use this simply to assess the extent of the corrosion by light scraping or tapping the affected areas.
So no poking or heavy scraping?
No, definitely not. The use of the corrosion assessment tool must be restricted to ascertaining whether the failure criteria has been met or not.
And while we're legitimately lightly tapping with the corrosion assessment tool, it's important to listen to the sound, isn't it?
It is, because excessively corroded areas or metal that's been treated with filler will emit a much duller sound than unaffected areas.
Right, can we move on to the fail criteria?
OK. Well, let's assume then that we've found excessive corrosion within a prescribed area.
And I assume a hole in the metal caused by corrosion is considered excessive?
Yes, it would, even if it was a very small hole. Also, if so weakened, when using finger and thumb pressure, any panel didn't feel sound, or when using finger and thumb pressure, or the corrosion assessment tool caused a hole.
So a fracture or inadequate repair within a prescribed area would also constitute a failure?
Yes, it would. However, deliberate modification or severe distortion within a prescribed area should only be rejected if the component mounting or the load-bearing member or supporting member or supporting structure or supporting panelling, if the strength of those parts have been significantly reduced.
OK, so what defines an inadequate repair?
Well, if you don't mind, Robert, we'll have a look at repairs a little bit later on. But now might be a good time to have a look at the fail criteria for structural defects outside the prescribed area. So let's go this way at the back.
Good idea, and if I remember correctly, this is covered in section 6.1 of the inspection manual for body and structure.
Well, most of it is, yeah. And if you remember figures 1 to 4 in Appendix C, help testers identify the main load-bearing members on various types of vehicle construction.
And apart from section 6.1, is there anything else we need to consider?
Well, there is, yeah. Section 6.6 covers assessing structural defects around tow bar mounts.
I'd forgotten about tow bars, but if I remember correctly, section 6.1 covers vehicle structure, body security and body condition.
Spot on, mate. Obviously, to make those inspections and to look at those areas, we're going to need the vehicle up on some kind of a hoist or maybe over a pit.
So what are the failure criteria for structural defects outside of a prescribed area?
Well, that would be any deliberate modification, excessive corrosion, damage or fracture, or even an inadequate repair which adversely affects the brakes or steering by severely reducing the strength or continuity of any main load-bearing structural member.
So a big difference between the standards within a prescribed area compared to the rest of the vehicle structure.
Well, that's true, but we must remember that we're only talking minimum standards here, Robert.
And are those failure criteria the same as for body security?
No, they're not. For body security, we need to inspect the body and chassis within 30 centimetres of any of the body mounts.
I guess the usual suspects apply then: deliberate modification, excessive corrosion, damage, cracks or inadequate repair to a load-bearing body or chassis member which seriously affects its strength within that 30-centimetre area.
Great. We'll make a tester out of you yet, Robert. But you know, it's also worth remembering that while we're checking for defects within 30 centimetres of the mounting points, it isn't actually a prescribed area. So the vehicle will only fail if the cumulative effect of those defects is likely to significantly reduce the overall body security.
I guessed as much, but what about the security of the body mounting brackets?
Well, we'll also need to check all the fixings, such as the brackets securing the body and its supporting members to the chassis or any subframes.
Plus the securing bolts, rivets and welds of all of these fixings?
That's right, we'll be checking for the presence and security of all the components, as well as for fracture, distortion, excessive wear and damage.
I'm guessing if there was a fracture or corrosion within 30 centimetres of a body mounting bracket or say a securing bolt was loose or missing, that wouldn't be a reason for failure.
No, like we said earlier on, individual defects won't be subject to failure unless their cumulative effect is likely to significantly reduce the overall body security.
So basically the body or its supporting members to the chassis would have to be so insecure that there would be a clear danger to other road users.
That's right. Or if the body was so displaced in relation to the chassis that it might lead to loss of control of the vehicle.
Which would obviously be very serious. And we need to check the body itself for excessive corrosion or damage?
Yes, that's right. And we'll also need to check for sharp edges or projections which makes the vehicle dangerous to other road users. And this includes pedestrians, of course.
But the sharp edges or projections must be caused by corrosion or damage?
That's right. If it was, say, a sharp edge produced by deliberate modification, then that in itself wouldn't be reason for rejection.
Now, this vehicle doesn't actually have a tow bar, but if it did, the mountings wouldn't be a prescribed area. So does that mean that the failure criteria would be similar to that for the body?
Well, some will, but not others.
Oh, tell me more.
Right, well, for a start, we're still going to be looking at the condition of the body or structure within 30 centimetres of the tow bar mounting.
Even though this isn't a prescribed area?
That's right, even though we will be checking the same items as before.
Deliberate modification, excessive corrosion, damage, fracture or inadequate repair?
That's right, and these checks will apply to any load-bearing structure or supporting panelling within 30 centimetres of the tow bar mountings.
Right. What failure criteria apply?
Well, it's slightly different again for tow bars. You see, the reasons for rejection will apply if any of the defects affect the strength of the chassis or body to such an extent that the security of attachment of the tow bar is significantly reduced.
So a fair bit of variation in the criteria across the different items to remember then. What's next?
Right, well, we have a vehicle up on the hoist here. Why don't we have a little walk underneath that, and so we can see some of the areas we've been talking about.
Great. Some manufacturers use thin-gauge steel pressing for some steering and suspension components to save weight. So these types of components require the tester to be extra vigilant.
That's right, because the design of these components means that they're trying to minimise material usage but also maximise component strength. They'll often form a C shape or a U shape, and as a result of that they can form traps where road dirt can collect, and obviously the road dirt may have salt in it, and this can produce sometimes very serious but also very localised corrosion points on these parts. But I tell you what, why don't we get another car on here which has got less of the plastic underskirts attached to it so we can see more of the suspension components.
Right.
Right, Robert, if we come under this vehicle, first of all, on initial inspection, any severe corrosion might not be quite so obvious, but a closer examination might reveal that there is some significant material weaknesses. OK, and if that was the case, after visually assessing the component, the tester may need to investigate further by using the corrosion assessment tool for light tapping, or even just some light scraping to be able to do a proper assessment of the extent of the corrosion.
And what about the components where it's very difficult to get access with the corrosion assessment tool?
Well, we accept that there are occasions when that might not be possible, so it is permitted to use another blunt instrument, but you must take extra care so as not to cause any unnecessary damage.
And if there was a serious reduction in the overall thickness of the material, that would be a reason for rejection?
Yes, of course, and also if there was a hole or a split in it.
And is it acceptable to have welded repairs on highly stressed components?
Well, normally it wouldn't be, but however, if that highly stressed component is made up of welded sections or welded parts, then it would be acceptable, provided it was at least as strong as the original design. Now, I've got some samples over here on the bench to show you about the various kinds of repairs and bonding processes that the testers may well come across. If you'd like to have a look.
Yeah, let's have a look. Oh, they look great. We'll have a look at those in a tick.
OK.
Do repairs in prescribed areas need to be as strong as the original design?
Yes, they do. And the tester will need to check that any materials used are of the right gauge or thickness, and that any plating or welding extends to a sound part of any load-bearing member.
But not all types of welding are acceptable, are they?
No, they're not. There are one or two rules that we need to adhere to. Firstly, only continuous seam welding is acceptable for patch repairs, even if the patch extends to beyond the prescribed area.
So no spot welds, then?
No, spot welds are OK, provided the original panel is attached to an existing spot welding flange, and provided that the flange of the original damaged panel has been removed.
What about stitch or plug welds where the original panel has been replaced?
Well, they're fine because they're considered an acceptable alternative to spot welds.
These days, some manufacturers use MIG brazing, or say a combination of adhesive bonding with riveting during manufacture. What then?
Well, one problem here is that manufacturers may recommend a completely different joining method for repairs than they used in the manufacture of the vehicle. So it's therefore possible that you may see different joining methods for a part of the vehicle that's been repaired, and they'll be completely different to the side that hasn't been repaired.
And of course that could be confusing for testers.
Absolutely, so therefore the tester should accept these repair methods unless they are obviously inadequate.
But some methods of repair must be unacceptable.
Yeah, they are. Gas brazing, soldering, adhesive bonding, fibre reinforcement, body filler, they're all bonding processes, but none of them are acceptable for repairs to load-bearing members. However, they will be seen as to be acceptable for other repairs.
I thought you said earlier that brazing and adhesive bonding were OK.
MIG brazing is, but not gas brazing, and often it's very difficult to be able to tell these methods of repair apart. However, adhesive bonding is OK when used in conjunction with riveting or an amalgamation of the other repairing or joining methods.
OK, Jake, take us through these samples.
Right, well, first of all, let's have a look at this one. This is a simple bonded joint, and there's nothing else in there but bonding adhesive. It's just two pieces of metal with an overlap. But this is, you find this more and more in common use on newer, more modern vehicles, and it's an acceptable method of attachment and even repair in some non-load-bearing sections of the vehicles. This is an advance on this method of joining. As you can see, we've got similar pieces of metal here. We've got the bonding joint in between, and before the bonding adhesive has finally cured, they've actually reinforced it by using fusion spot welds here. And these have to be applied while the adhesive is still soft. And there again, that is another recognised acceptable repair method used in modern-day vehicles.
And this type of join could also be done with riveting, couldn't it, and the bonding?
It could do as a combination, yeah. This one here is a plug MIG weld. OK. We've got two pieces of metal. This top piece of metal has been had holes drilled in it, and they've been elongated to allow a greater area of adhesion, and these have been electric MIG welded, and that gives an alternative joint to spot welding. OK. This one here is just a simple lap joint using MIG brazing, and as you can see, we've got two pieces of metal here, and on the end you can see we've only got a small overlap, but that is a perfectly neat MIG braze, and it's a nice repair.
Now, this is fine, but it must sometimes be difficult for a tester to tell which repair method has been used once it's been covered in paint or underseal.
Well, that's true. But, you know, if the tester has any doubts about the quality or the method of repair, he should simply pass and advise.
On some vehicles, the prescribed area may be a plastic or composite structure with no metal reinforcement. How should a tester assess these?
Well, those non-metallic structures need to be assessed on their own merits. So any sign of weakness due to cracks, separation, delamination within any prescribed areas will be reason for rejection.
How about if, say, a component was flexing excessively on its mounting?
If it was flexing to the extent that it was clear that it was likely to become loose or detached, then that would also be reason for rejection.
So are repairs permitted to plastics or composite structures?
Yes, they are, but not within a prescribed area. And it's also unacceptable to use plastics to replace or reinforce corroded or weak metal within prescribed areas or load-bearing sections.
So what standards apply to repairs to non-metallic structures outside the prescribed area?
Well, these are perfectly acceptable, as long as the tester is satisfied that the repair appears as strong as the original structure.
OK, but what if a tester finds a load-bearing panel has been removed or replaced with a panel made from a different material to the original?
Well, on a vehicle with integral construction, its whole strength and stiffness may be seriously weakened by the removal of or replacement of a panel made of a different material.
So if a modification has significantly reduced the strength and stiffness of a structure, the tester should fail the vehicle under the appropriate section?
Absolutely right. But remember, if the tester has any doubt about the effect of the modification, then he should pass an advice.
And if the vehicle were in such a condition owing to damage, corrosion, poor repair or modification that it could cause injury to a person or further damage to the vehicle, then the tester should refuse to test.
He certainly could, yeah, you're right. And to be fair, from what I've seen of your welding, it might just prove necessary.
It's some of my best work, Jake.
Well, I mean, perhaps you were just having a bad day.
No, I'm sticking to the more artistic side of welding. What do you reckon to that?
Well, yeah, it's very nice. What do you call it?
It's called exhausted.
Good grief, give me strength. Come on, listen, I want to talk to you about this car. It's very good of you to lend us your wife's car, as it happens. Tell her I don't want her to worry too much because, trust me, I'm an expert, all right? We know a geezer who's